Alright, we're live. There's some technical stuff I need to go before I can start coding. So this is gonna take just a moment. Okay, let's see if this works. Okay, let's see if this works. Alright, and we're ready to start coding. So today I will continue from the lessons that we had this week and the materials that we had this week. And I'm gonna extend some of the concepts that we learned. So for this project, or for this stream, I created this hello.html file, and here I'm gonna create the HTML DOM using the same exclamation mark method that we used earlier. And then I'm gonna create a file called hello.js. And I'm gonna call that file. Seems that my editor isn't working right now, so I'm gonna restart it. There's some issues with my editor at the moment. Okay, let's hope that now the editor will work a bit better. So let's see. So I'm gonna include that file that I just created, the hello.js. And I'm gonna create some content for the page itself. And I'm gonna reload this page, so hopefully no, that's broken. Gonna restart that. Okay. Good. So now we have this page opened. Hopefully it's visible from the stream as well. Yes. So what we're going to do today is go through some of the basic stuff that we covered on the materials earlier, and I'm gonna introduce some new concepts as well that we're gonna go through tomorrow and next week. Gonna change the title to be Stream Live Coding. It seems that my laptop is really slow today, so bear with me. Alright, so we can create variables. There's still some issues, bear with me for a while. Okay, hopefully now it would work a bit better. So I'm gonna create a variable called my name, and I'm gonna put a string into it, and then I'm gonna create a variable called my age. Okay, I don't know what that is. My age, so let's put 13. And then I can log this. So my name is my name. And you can see in the console that we now printed the content of the variable my name. I can change my name into something else. So you see it takes the value from my name. And I'm gonna console log my age as well. So notice how I don't have to put any spaces here. The browser DevTools will automatically add the spaces when it detects that there's a comma right here. So what it will do is it will do a kind of string concatenation, and you remember string concatenation was adding two strings together. So concatenate equals something like this, for example, 1 and then 2. So now you can see that it says 1, 2. And if I do some mathematical stuff, you can see that it actually does the math now, that it sees that both of these values are numbers and these are strings, so in this case it will do a string concatenation, in this case it will do a mathematical operation. And if you did the tasks that we had for this week, for one of the tasks you needed pi. So the way you get pi is by using the math object from mathematical built-in functions that JavaScript offers for us, and from here you need pi. So I'm just gonna console log this. And we can see what JavaScript thinks pi is. So it's not counting it until infinity. It's giving you the best estimate of some decimal points. Then we also had conditionals and if statements. So I can create a variable which will have a conditional check on it. So const is my math valid? Let's see, my math equals to 3, and I can console log this value. Is my math valid? And now you will see it's valid. Or one other way to check that would be with the if statement. If is my math valid, then let's console log something. So in this case, yes, it is. And now it's difficult to see what the context of this text is. So let's add something here. And I want to do an else statement as well. So now you see we execute this branch. This is also called a scope or block of code. Next week we will learn about scopes. So this is a scope and this is also a scope. And both of these scopes will have their own namespace. So if I define a variable inside here, I cannot access this variable outside of this scope. So if I try to use it here, let's console log this. It should not be possible. So now I need to change this statement. So we could actually, I'm gonna move this beneath here. So let's see if this happens. So now you see, even though I defined this variable, JavaScript doesn't see it because it's been defined inside a different scope. So these curly braces define scopes, and everything you define inside them is in their own namespace. And unless you define a variable outside of the namespace in the sort of global namespace, for example, or the space or scope of the parent function or whatever, then you can change the values as we did in some of the examples this week. But if you define variables or anything inside the scope, it will not be visible outside of that scope. The same would happen if I would drop this into a scope. Now it would say, is my math valid from line 21. So this line, it says it's not defined because now this variable has been defined inside this scope. So all of these if statements, they create their own scopes, their own address spaces in a way. But I can of course access these values inside these scopes. So here you can see that it printed the value to be 1, but outside of that scope I cannot access that variable at all. If I would want to define the value inside this scope, inside here, what I would do is I would remove the keyword const and I would initialize this variable and I would initialize it as undefined, so it can be any kind of data. And as I save, now you will see that it's possible to use it outside of that if statement or the scope of the if. And if I change this my math operation, for example, let's add 10 to it, and now this should not be valid anymore, therefore this statement should not apply anymore, and then we would move to the else statement, the else branch of if statements, and we move to a different scope. So now you can see that the conditional is not valid anymore, it's false, and my variable is now undefined, and my if statement is now a bit different, giving me a bit different result. And I can do the same here with ternary operation. So ternary was the question mark, and then I would do a console log. I'm just gonna copy this, and then a colon, and I'm gonna copy that. So this is the same as this if statement, but here notice that I'm not defining any variables or calling them. Ternaries are not used to define variables, at least not in this sense. What I could do is I could build a ternary again. So I'm gonna comment here, ternary is some condition, question mark, if true, else if false. So ternary operation, if you see the question mark, you know that this is a ternary operation. So if this condition is true, we will go to the first branch. If it's false, we will go to this branch. So if I would like to define this variable using a ternary, then I would say, I would copy that here, and I would assign the ternary statement. So is my math valid. If it's valid, then we will return 1, and if it's not valid, we will return undefined. Because here you can see that it's undefined, and we initialize the variable without any value, so it's undefined. So let's keep it that way for now, and I save, and you can still see I'm gonna move this my variable here after if, my variable here after ternary. So now you can see it's getting the same values, and if I change this mathematical equation so that this statement matches, then you see that both of the console logs that we had work. They both return the same thing, and my var here variable has been defined in the same fashion. So sometimes defining values like this is useful, and sometimes it's not. Okay. Gonna see if there's any questions anywhere. Nothing. That's okay. So next, we've used string here, we used number, we did some string concatenation, we did some mathematics, we created the Boolean variable using a conditional statement. We used if statement and if else statement, and then I did the same thing with a ternary statement as well. So all of these defining variables and the types of variables that you can have and how the type is defined in JavaScript, they should be clear to you at this point. We've been doing lots of variable defining at this point. So I'm gonna move a bit to the next week stuff. So the scoping was one part of next week stuff. And then next week we will go through lists, aka also known as arrays. So an array is defined with these brackets. So in programming you will see lots of different kind of brackets and phrases and special characters. These define arrays or lists. This syntax should be same in most of the programming languages. There are some exceptions. For example, C++ defines lists a bit differently, and they call it a set, and they've inherited that from mathematics. But in JavaScript and in Java and Python and most other languages, lists or arrays are usually defined like this. And I'm gonna assign a variable, my list equals an empty list. I'm gonna comment out everything that we have for now, because we only care about the list at this point. So if I console log this list, you will see that the browser will now print me these two same characters and this small arrow here. So you can click the arrow, you can see what's inside of this list, of this array. So you can see that this is now an empty list, there's nothing in it, therefore the length is 0. And you can see a prototype, and from here you can see all the methods that lists have, or arrays have. And let me just Google mdn array. You will see the same thing here as well. So here they have defined an array with 2 values, 2 items, therefore the length is 2. So each array, if I go back, will have a length defined. So I can call it just by dot length. And you can see it shows 0 because there's nothing in my list. So that's an empty array and it has a length of 0. Then I can define some values into this list. I can either put just primitive values, or I can assign variables, I can assign other lists, I can assign all sort of data on this. And also an array has a type. So here the type is any with many times. So this syntax means that this list will have any kind of data, how many as you want. I'm gonna put 1 and 2. Let's see if my editor is smart enough to change it to number. So now it knows that this list is made out of numbers. And as I save, you see that my list length is now 2. I'm gonna remove the length. Good. So I'm gonna put some more console logs here. So we can see that we have a list with 2 values and the length is 2. And as I click here, I will see this sort of representation of this list. So these numbers represent the index, and this is the value of that index. So in programming, we always start at index 0. So if we have a list that has 5 items, the indexing will start from 0, and the last item, which is the 5th item, the index for that is 4 and not 5. So I'm gonna show you what I mean. So I can access the items from my list, or my index, my array. Item in index 0. I can access it similarly to how I created the empty list, empty array, by calling the specific index. In this case it was 0. So now you can see that the item in index 0 is the item 1. Similarly, if I console log item in index 1 and then I type here my list 1, we will see that the item in index 1 is 2. So 0 index and index 1. And if I try to access value that is outside of the scope of this list, or outside the length of this list, so let's say at index 2, you will see an undefined here, because the list there's no value in index 2, therefore the value of that index is undefined. And when you're programming with JavaScript, you will see undefined many times. And if I would now add a third value here, I can add string here as well. So now you will see that item in index 2 is my name. And here you can see that this list is comprised of 2 numbers and then a string. And if I click here, I can see that the length is now 3, similar to here. And again, we will have these prototype methods that we can use. I'll come back to those later on. If I would like to change, I'm going to duplicate this line. If I would like to change one of the values on this list, I can do it by reassigning a specific index. So I'm going to reassign index 2 to be the value 10. And as I save, now you will see that item in index 2 is now 10, but before that it was 2. And if I open this, you will see this sort of weird functionality. So here you have my name, and as this part was rendered to the development tools in line 49, before I changed the content, the rendering showed my name here, but as I opened it from clicking here, now it will show me the current value, and that's a bit bizarre. There are ways of opening this and seeing the value as it was when the list was console logged. And here I can access my list as well. So let's try another thing. My list at index 1 equals hello. And if I open this, let's see, that did not change, good. But if I now show my list content, it will show my the index 1 as hello. Can I see if there's any comments at this point? Nothing. No comments. Okay, that's good. No worries. So in these lists, now if I hover this, it will show that the type of this list content is either string or a number, but it's still a list or an array. As I define a list, I cannot define a value to go to specific index. Instead, the index will be based on the location where you put the value. So if I want to have number 4 at index 2, then I would have to put it here. And now you can see at index 2, the value is 4. So in programming, we always start at index 0 and end up in the length of the list minus 1. So I'm going to type it here. Index always starts at 0. Index always ends at length minus 1. And we often just simplify this to index always ends at n minus 1. So this is a bit more academic convention. So this list now will have the last index at 3 because it has 4 items on it. And if I try to console log items that with negative index, so -1 for example, it will give me an undefined again because there's nothing on index -1. Gonna duplicate this and let's try to define a value to index -1. That should not be possible, but it seems to be possible. So now as I print this list out, you will see that it has 4 items and it can't really handle the -1 here. So don't use index -1. That's not cool. So let's just use index 1 for example, and now I changed the item in index 1, which is the second item. Another thing that we're gonna go through next week is loops, and tomorrow. So loop is a basic construct to allow us to repeat some functionality many times. So it is comprised of 3 parts. First we define a value, let's say I is normally the value, and this is the starting point. Then we define how often we will loop, what's the end point. So let's say that I is smaller than 10, and the last one is the increment or the operator. So I will increment this value, and now I will just console log hello. So you will see that I actually console log it 10 times. It shows here 10 times. I can put in the value I here, so it will show it 10 times here, displaying the I at each moment of the loop. And as you probably guessed, or maybe not, you can also iterate a list that way as well. So here you see index 0, 1, index 1, 1, 2, 3, index 2, 10, index 3, Juha, and everything after that is undefined because there's nothing on those indexes. So I'm gonna do a quick for loop again. Let's define I again. So I'm defining I on this scope. So let's define I to be 0, and then let's say that I has to be less than mylist.length. So this is the way you got the length of a list. And then I will put the increment here. And now if I console log item in for at position, and let's say I, and then I'm gonna put my list and call the index I, you will be able to see only 4 loops. So this will loop as many times as the list has items on it, which is 4, as we saw from here. So this is a way to iterate through and list. And as it hover the length, you will see a tooltip. You will see a tooltip explaining what the length is. And again you will see the types of the list itself. So it's an array with strings or numbers, and the length is a number representation which gets the length of an array. This says that you can set it as well, but please don't do that. It will also tell you that it's one higher than the highest index in the array. So I'm going to open up the course material for this part. So this is the course material we're going to go through next week. And here you can see the for loop. So the for loop has 3 steps or three parts. First is the initialization. So I defined I to be 0, that's the initialization. Then I have the condition. This is just a Boolean operation, so we check that if number I is less than my list length, we will continue this loop until I is higher than my list length, and we will not, once it's higher, we will not execute the for loop anymore. And here we have the step. So here we're incrementing the value I with 1. What we could also do is I could increment this with 2, as you remember the syntax. So now you see we only did 2 loops, even though we have 4 items. I can do the same here as well. So incrementing by 2, so we will skip every other one. I can increment by 10, which doesn't make much sense because we are going to 10. But let's go to 100, and now we will see indexes 0, 10, 20, and so forth, all the way until all the way to 90. If I change this comparison operator here to be less than or equal, then we will go all the way to 100. But most often we will do for loops in about this fashion. And we can run the for loop as many times as we want, but depending on your computer, that might be a slow operation, and depending on what you do in the scope of that for loop. So again, we have a scope here. So everything you define here, inside here, will not be available outside the scope of this for loop. And for loop is different from if in that sense that if we define, I'm gonna just change this to 10, if we define any variables inside here, these get defined every time again and again. So the loop will execute this 10 times, and here we break the rule of not redefining const variables, but this is each time this is a different space, different scope. So if we can define variables and they will not be available outside of the scope. So if I try to if I try to access the hello variable outside of that scope, it should give me an error. And also you can see that as it gave an error, my next for loop is not being executed. So the execution stops at errors. Okay. So those were the basics of for loop and scopes. So for loop has three parts: initialization, then the condition, and the step. So I could kind of write this as an if statement as well. So it would be something like this. So let's say let I equal 0 if I is less than 10, then do something, and then we would increment the I, and after this we would move back to this if statement. So we execute this condition here. We execute this as many times as this is true, and once this is false, we stop executing this one. And also we execute this every time when this is true. So if the condition is true, we will increment the value and move to the next. But the order of execution is not that, it's a bit different. So first we will compare if I is less than 10. If that is true, we will start executing the for loop, and once the execution has, or that scope has been executed from beginning to end, then we will increment and do the state, the comparison again. So it's kind of jumping back to itself as many times as the condition tells the for loop to do that jump. Okay, if I save this, there should be no issues. Oh, hello is not defined. I'm gonna comment that out. So we cannot call variables outside of the scope. They were defined in. So again, if I would want to define the hello, I would have to define it before, and then I could call it. And now it will always be 1 as I defined it to be 1, so I can also define it to be the index or the I variable. So you will see now it is 9, which is the last value. So why do I use for instead of let? So this for is a keyword defining that we will execute this scope based on this criteria. So this is a different keyword. For keyword defines that we will do something many times. So I can write code like console hello 1, let's say 2, 3, 4, 5, 6, 7 and so forth. Or I can create this sort of for loop which will do all of this with just one line here. So I can repeat functionality. So the let keyword defines variables, but the for keyword defines that we're gonna repeat something as many times until the condition is false. So it has 3 parts. First we initialize some sort of value. This could be, for example, my variable again, or it could be image, it could be hello or phone. Often it is I. If you define this to be something else, let's say check. Let's say it's check. Then I would also have to define this as check and this as check. And if I call this now, we will get an error because I is not defined yet. So I have to change this one as well and this one as well. And we still had this one, so yeah. So more often we use the word I because it's short to write and it's like de facto way. There are only a few locations where it's completely okay to use single letter variables, and for loops is one of those places. But on other times when you're defining variables like with let or const, please don't use single letter variables because they are not readable. But here, because we know that we are in a for loop, we understand the meaning of I. Yeah, so for is for looping values, it is for repeating some action many times. Let me comment all code out again, so we'll get a fresh start. And let's do a calculator, pretty short, which will increment values. So let I equal 0 again. Let's say I has to be less than 100. Let's increment I by 1. And I'm gonna initialize a value here. So let's say my calculator. Let's define it to be 0. And here let me increment this value by 10 every time as I loop, and then after the loop I will console log my calculator variable. So now we get to 1000. So we looped this operation 100 times and we got to 1000. But that doesn't make much sense, so let me change this value to be 1, and I'm gonna multiply it by 1.1. So let's see where we get into. So this could be some sort of compound calculator. For example, for every year, for 100 years, you will get 10% extra money, for example, and in 100 years you will have, for example, that amount of money, or whatever this could signify. And again, we can increment the values a bit more, so the result will be a bit smaller. We can also, I'm gonna just put it like that. We can also decrement these values. So I'm gonna copy paste these again. I'm gonna rename this to be my calculator 2. And let's say I want to define an starting value to be 100. And I'm gonna define here that I is 100 instead of 0. And then we're gonna see that if I is bigger or greater or equal to 0, then let's go down, and I'm gonna decrement the value as well. So now we will go from 100 to 0. Gonna change this to be second result, and this is gonna be first result. So now we decremented this value all the way to -1. But actually what I wanted to do is to put it to 0. So I made this classical off by 1 mistake. So let's say I is greater than 0, and now the end result will be 0. And I can combine this two logic with lists again. So I'm gonna initialize an empty list. I'm gonna initialize it with const, and I'm gonna create a for loop. Let's say I is 0, and let's see that I is less than 100, so we're gonna put 100 items into this list. And how you add items to a list is by calling this push method, and I'm gonna push the I variable. So here you can see what push does. So it adds new elements to the array, it pushes them to the end of that array, and it will return the new length of that array. And the length will automatically change as well. So let's push I into that. I'm just gonna console log this list. So now you can see that we got lots and lots of items into our list. And if I open this, it will show all of these items, and it will show the index of it as well. But I don't want my values to start from 0, so I'm gonna put the value as I plus 1. So this operation, it does not change the value of I, it just gives the result of I plus 1 to this push method. So as I saved, now my list will start from 1, but the index is still 0, that's correct. But the first value is 1, and let's see, the last value is 100. The length is 100, but the index of this list is the length minus 1, because the index starts from 0. Okay, good. Good, you got that. Yeah, feel free to ask any questions. That's why I am here. Okay. So now we have this list that I populated on my machine. My machine is slow today, so I'm just gonna put 10 items. It's a bit faster for me to click these, and yeah. So you see, it goes in the order where I push the items. So 1, 2, 3, so forth, all the way to 10. But if I want to push them in different order, so I want to push 10 as the first one and 1 as the last one, so in reverse order. So what I'm gonna do, I'm gonna copy paste this line of code. I'm gonna change this variable called mylist reversed. And now I have to change the logic of this for loop a bit. So let's say I want to push 10 items. So instead of defining the 10 here, I define the 10 here. Then I change the, this sign around, and I remove the 1 from there as well. And then the plus operation becomes minus operation. And I'm gonna remove this for now, so we will see the value. So now we have at index 0 we have value 10, and at index 9 we have value 1. And the array contains methods where we can reverse the order of the list without doing the for loop. So I'm going to show it in here in this DevTools, so my list. So here you can see it is in order from 1 to 10. But if I type in mylist.reverse, it's a method, so I just put the braces here, press enter. So now you see that my list was reversed, and if I call my list again, you will see that the reversing has actually been saved to this variable. Sometimes you want the list to change when you do the reverse. Sometimes you want to just return the reversed new list and keep the original list intact. Then you have to do a bit more code for that. I'll leave it to you for now. Maybe we'll go through that in the lectures. Let's see. But this was 2 different ways of creating lists. One going from 0 or from 1 to 10, and the other one going from 10 to 1. The reason this is 1 on the last as the last item here is because this condition, so if this for loop will be executed until I is no longer bigger than 0, and 1 is the last full number that is bigger than 0. So that's why the last one there is 1. If I would put greater or equal, we would see we get 1 extra here. And I can actually go to negative numbers as well. So let's say -10. So now we will have values from +10 all the way down to -10. So these comparisons don't have to be positive values. And you can also do this in whatever order. So you can keep this kind of structure So if you want the to have the less than sign, so let's say 10, let's say 0 is less than I, we can do that as well. So we don't have to put I always on the first part, but that's usually the convention. So you would usually order the condition statement so that you have the variable first, then some sort of operation or check, and then the other value. But this is fine as well. And we can again decrease with 2 numbers, for example, if you only want all the other one, all the even numbers, or we can have 3. So now we will have 10, 7, 4, and 1. And we can do some weird stuff as well. So this might be reasonable, might not be reasonable. But there are many different ways of doing this. And then we can divide as well. So let's see if we want to divide by 2. That got even weirder. We got lots of values. So I'm just gonna put minus minus back. So just so we keep our sanities. Yes, so if I push, there's a question about if I can push it in order, like 2, 6, 2, 4, 6. Yes, I can do that. So I can increment these values by 2, but here I would have to then start at value 1. So now you can see 2, 4, 6, 8, 10. So we can always change this initialization value as well. And if I set this value to be, let's say 10, this should be an empty list, because this statement does not apply even once. But let's just keep it at 1, so we can push every other even number. And I can increase this as I wish. And because this is a condition, I can have multiple ifs here, so AND operator works as well. It's not commonly used, but we can do that. So I'm going to create a variable called k, and let's say k is smaller than 10. I'm going to define let k equal 0. So now this will always happen. So you will see 50 items here. But if I go inside this scope now and I say k plus, what would I plus it with? I'm just gonna plus 1 for now. So you will again see that we only got 10 values, even though that I check is 100, but because the k has to be less than 10, so we only get 10 values. What I can do is I can do some weird stuff again. So I can increase k, for example, by 0.3, and we'll get 34 items. Or what I can do is I can increment k by 1 again, but I'm gonna wrap this time it inside an if statement. So if, let's say, I modulo 2, let's see what happens now. Again, okay, let's say model 3. So I can do this kind of if statements and conditionally increase or change the value of k. Okay, so let's say I only want to change value k once we've gotten at least 50 loops. So after I is 50, then we will start incrementing k. So you see it gave us 35 values here. If I would increment I with 1 and k with 1, you now see that we will start incrementing k only after I is greater than 50. Therefore we will have 60 items in our list. Okay, so for loop, initialization, then semicolon, condition, semicolon, step. And on the step you don't put semicolon at all. So let me put a semicolon here. My editor says that there's something wrong here, and the browser is telling me that there's something wrong here. So don't put a semicolon on the step. And the loop will be running as long as this condition, the second part, equals to true. So let me do one more example. Let I equal 0, and let's say true. Let's say that I equals 0, and I'm gonna increment, and let's say console log, and I'm gonna put the I here as well. So now this statement will run as long as I equals to 0. So as you can see, it runs one time. If I put here I equals 1, it will run 0 times and nothing will be rendered. I'm gonna comment code again, so we only get this last part, so we get nothing. But if I initialize I with 1, we get one loop. If I initialize with 2, nothing happens. Okay, so let I equal 0, and let's say we want to run this as long as something is true. So if I would do it like this, my computer will most likely set on fire. So it will keep on running for loops as long as I stop execution. So I'm gonna set this to be, as you can see, it keeps on running all the time. I might need to do a hard reset now. So I'm just gonna close the tab if I can, and then with Command Shift T I'm gonna reopen the same tab. So what I created was an infinite loop. So I'm just gonna copy this code. So this is what we called infinite loop. So infinite loop is a loop that will never stop execution, and we don't want that. So I'm gonna create again a variable called let should I keep running equal to true, and I'm gonna put that variable here, And now this loop will run as long as this is true. And I'm gonna put a if statement here. If I is greater than 10, I'm gonna change this value to be false. So now you can see that once I is greater than 10, it will stop execution, or greater than and equal. So this is setting up the for loop, this is keeping it running, and this is increasing the initialized variable. And let's do one more example with for loops. So I'm gonna create a for loop with EI again, let's say that, and then I'm gonna put the true, which is a no, and so now this loop would run forever, but I'm gonna create, first I'm gonna create console log, just so we get something out. Hello again, and let's put I, and here I'm gonna put if I is larger than, let's say, 5, I'm gonna introduce a new keyword called break. So this keyword means that the for loop will stop execution when the JavaScript engine finds this line. So when this line is executed, the for loop will stop. Okay, and I'm gonna introduce another one. So I'm gonna put this to be 20. I'm gonna duplicate the console log. So let's say start, end. I'm gonna move the end here, and let's say middle. Okay, so now we will see start, middle, and end. And here you can see start 20, middle 20, end 20, and start 21, middle 21, but no end 21. So everything after break will not be executed. And one more keyword called continue. So if I'm gonna create if statement, and let's say that if I is greater than 10, continue. So you can see that keywords are in this kind of purple pink color. So if I is greater than 10, we will continue. So this keyword will stop the execution of the for loop, but it will stop the execution of that scope and continue to the next one. So from here, after this is true, it will jump back to here. So let's see what happens. So now we only see starts. We don't see, oh, I created an infinite loop, that's nice. So I'm gonna move this to here, I'm gonna move that to the middle. Okay. So sometimes we accidentally create infinite loops, and that's what just happened. So I need to kill this tab again. It's gonna take a while. And I'm gonna reopen it by Command-Shift-T and inspect. I'm gonna open the console tab once my tools open up. Okay, so if I reload this page, we will see a lots of text here, but we don't see the end. So we will see end when it's 10, and everything below this will not be executed after this equals to true, and once this equals to true, the whole for loop will stop execution. So continue will continue to the next iteration, and break will stop execution. So for loop will iterate this scope as long as the condition is true. So this could also be something like this, for example. Now we don't get to 100 because we will break at 20, and we don't see the end after we've done 10 loops. So before that we see start, middle and end, and after that we only see start and middle. Okay. Just gonna check one thing. Okay, good. We have lots of viewers today, that's nice. Next, I'm gonna just check what we have here on our course material. We have while loops. So let's go to while loops. So now that we know that for loop will continue execution until the condition is no longer true, for example I to 10, so we can use that same knowledge on the while loops, and while loop is a bit simpler, at least the first line of while loop is a bit simpler. So while is a keyword, and let's say I will iterate this until I'm gonna comment this out so we don't see the same twice. I'm gonna iterate until I is less than 10. Okay? But there's a problem now. I have not defined I. So I have to define I outside. I'm gonna define it as 0. And now if I save, I would end up in infinite loop again, because I never increment, I never change this I value. So inside here on the last line, it's often the last line, I will increment I with 1. And now I will just do console hello from while, and I'm gonna put the index there, not the I. So now you saw we'll iterate this scope, again a scope, 10 times. And I can do this in a different way as well. So let's see, I'm gonna reset I to 0. I'm gonna put true here. I'm gonna increment I by 1. So if I would save now, I would get an infinite loop because this statement is always true. But I can create this if statement again. If I is less than 10, if I is less than 10, I can break. So while loop will also have the keyword break. Sorry, if I is larger than 10, let's break 10. So for while loop will have the same keyword for breaking and continuing as for loop. So I can write continue here as well. So now it will keep on continuing. It never reaches the if statement. You can see that maybe the color of this if statement changed a bit, and my code editor is now saying unreachable code. So I'm gonna change this to be if I'm just gonna remove that for now. Okay, and I need to kill this tab again and reopen it again and open the inspect tool. And open the console tool. So if your code goes into an infinite loop, just a simple example. This is an infinite loop, and if your code goes into infinite loop, then it's not fun. You have to kill the tab. If you're coding Node.js, for example, you have to kill the process. So the tab in browser is its own process, and we call it hanging when it's non-responsive, and it becomes non-responsive when it's just infinitely doing some operation, and here it was just infinitely console logging an output. So let me just show you what happens if I comment this out, and there's nothing here, so we will see a value incrementing here. So this happens forever, and you can see how often my browser executes this. My laptop is old, it's low, so it's not happening very often. Your computer might be a bit faster. The way I can stop this now is by killing this tab. But let's keep that running for a while so you can see how it increments. At some point it will use pretty much all of my memory, and then my browser will crash. So at this moment it's using 200 megabytes of memory, but that's the whole Chrome renderer for this process. Let's see if it goes up. Okay, now my other programs are starting to fail, so I have to kill this tab. And you often have to press twice in order to stop that tab. Oh, I'm just gonna comment this code out. I'm just gonna reload it just in case. So loops are powerful tools for doing things many times in a row, redoing the same action, for example, or doing some action that requires different values, for example, or whatever you want to do. One thing you can do is like list all the items in an array, for example. You can push into arrays in specific order, for example. There's many things you can do with arrays, and you can crash your machine as well. That happens. Sometimes it happens often, and especially in the beginning it happens often. But as long as you know that once you close the tab, you are good to go. Just reopen it. Make sure that you comment out that code that was causing the infinite loop before you reopen the tab. Otherwise it will do the infinite loop again. So while, a bit shorter syntax than for loop, but same concept. Remember to increment your values. Pretty much usually it's the last one, last statement, so this would actually be here. I just selected that text and I pressed Alt and arrow key down so I can move code. But yeah, usually it's a good idea to have the incrementation here at the end. And again, you can increment as whatever rules as you want. We can also increment by 1000 or whatever, so you will see that now we did this loop twice because first we had the value I was 0. After that we incremented to 1000. We started doing the next loop. Then we got into the if statement and stopped execution. So if you would want to stop, if you would want to prevent functionality like this happening, move this if statement to the beginning of the while loop. So now you have the break on the beginning, your actual logic in the middle, and then the step in the end. And now you see that we only did this action once. So while loop, this is the initialization, it's outside of the while loop. This is the condition, and this is the step. And let's see, MDN while. So you can always Google these keywords or whatever, like types or whatever you want to know, just put MDN on the top. So here you see, while statement creates a loop that executes a specified statement as long as the test condition evaluates to true. The condition is evaluated before executing the statement. And here you see a similar code as well. And this is the syntax. So while, condition, and then in the body of the while or the scope of the while you put the statement. This is worth reading, and also for loop MDN article is worth reading. I highly recommend you read these two. And then I'm gonna Google the for MDN again. You have this loops and iteration article here. Please read through this as well. I will go through loops and iteration on our material as well, but this material will go into more detail. It will show you different statements, a lot more than we go through on this course, and this article will go into much more into detail than I will go. So if you want to know how these loops work, it's worth reading the articles made by Mozilla. So if I go back on our material on the top, so contents of tomorrow on Friday will be about new stuff, arrays, loops and iteration, scoping, built-in functions, and how to make your own functions. And today we went through these three. So we are in good shape, at least all the ones that have been listening on watching this stream. if you want to go through this course material before tomorrow, that's recommended if you have time, but we will go through this tomorrow as well. Arrow iteration is something that I showed you. There are a couple of different ways of doing that. Tomorrow we will go through the other ways, but this is one of the ways that we already practiced here. I'm gonna put this code, I'm gonna remove all the comments and make sure that it works and clean it up a bit. I'm gonna put the code that we wrote today to Gist, and I will put the link onto this stream. Now I'm gonna check if there's any questions at the moment. No questions. I think I'm gonna finish up at this point. We went through a lot of new stuff. We did some recap on lesson 1 stuff, and we will continue tomorrow doing a small recap on lesson 1, and I have also some example solutions for your tasks, and then we will continue with going through arrays, loops and scoping and all of that. The order will be a bit different than on this stream today. But in a nutshell, looping will prevent you from writing code like this. Instead, you can write code like this. You can always copy paste these snippets of code to your console and try them out yourself. But if there's no questions at this point, I will end this stream here. There were some technical difficulties for me in the beginning, so sorry I was a bit late. We'll stream again next week.